Question number 57 asks us to evaluate this guy right here. This notation, I equals 1 at the bottom, tells us the first integer we are plugging in for I. The top number, in this case 6, tells us the last integer we're plugging in for I. And the big sigma here tells us that we're going to add those things up. So we start by plugging in the bottom number. Plugging in 1 gives me 1 squared minus 1 plus 3. Plug in 2. Gives us 5. Plug in 3. Oops. Gives us 9. Plugging in 4. It's 15. Plug in 5. And plug in 6. Gives us 33. And we know to stop there because 6 is the top number. Sigma, again, tells us that we are adding these up. So here I've got 56. Here I've got 24. That's 8. So what I got? 32 plus 56, 88. Part B on number 57 looks very similar. But if we try to do it that same way, we're going to have to plug in 1, 2, 3, 4, all the way up to 82 and add them all up, which I guess could be done. It's not going to be easy. It's certainly not going to be fun. So instead, let's start plugging in some numbers. If it's a calculator problem, you could just type it into your calculator, evaluate it. But if I start plugging in things, plugging in 1 gives me 64. Plugging in 2 gives me 67. 9 plus 61. Plug in 4. 12 plus 61. Plug in 5. 15 plus 61. And hopefully we can recognize that this is an arithmetic series. Plus 3, plus 3, plus 3, plus 3. And we're adding them up. So we can use the formula for an arithmetic series. It says the sum of the first n terms is n over 2 times the sum of the first term and the nth term. So in this case, n, the number of terms, well, I plugged in 1, 2, 3, 4, 5, all the way up, and I'm plugging in 82. I've got 82 terms there. A sub 1 is 64. A sub n, A sub 82 would be the 82nd term. If I plug in 82, I get 307. So I've got 41 times 371. So 41 times 371, we could do that without a calculator there. Gives us 15,211, I believe. Okay. 15,211, which is correct.